Lesson 10.7, Geometric Sequences. I've touched on this before because it's actually geometric sequences are very much tied in with exponential functions. You may or may not see the link. If you ever graph an exponential function and graph a geometric sequence, it becomes quite obvious. But regardless, let me give you some examples. Geometric sequence where each term is multiplied by what we call a common ratio. And we say the common ratio is R. So if we look at this first sequence, 1, 3, 9, 27, 81, common ratio is obviously 3 because we're multiplying by 3 every time we go. Next one's a little trickier. How do we get from 64 to 4/8? Well, we don't want to figure that out. We want to let the math set us free and then check our work. So I know that 3/16 is going to 48, 4 going here. So the common ratio should be 3/4. Let's check it out. 48 times 3/4 better get us 36. Looks good. So from here to here, it's times 3/4. And with a fraction like this, I would actually check it again and see if that's the case. You can do that if you want. Looks to me like it works. So, like I just said, the best way to do it is just divide successive terms. See if it's geometric, and that way we'll find the common ratio. So R should equal -8 over 4, which is -2. R should equal 16 over -8, which is -2. So R equals -2. Down here, R should equal 72 over 60, which is complicated. I'll have to break this down piece at a time. Six-fifths. Wow, that one was hard. And it should also be 86.4 over 72. I'm going to use my calculator on this one. I'm going to use the math fraction button. I get 1.2, which I don't need the math fraction button. I know that's 6/5. So R equals 6/5. Not too challenging. You can actually write a formula, and this freaks people out. The nth term, meaning the 5th, 6th, 7th, 12th. In this case, this would be the first term, the second term, so on and so on. R is a common ratio. A1 is the first term. Always find the common ratio first. So for example, write the formula for this one. Not too hard. Find R first. R is -15 over 3 equals -5. I don't trust myself. I'm going to check the next two terms just to be sure. And sure enough, looks like I found a mistake. This should be 75. So we get 75 over -15 is -5. There's our common ratio. This is our first value. So A sub n, any n value we want, is equal to 3 times -5 to the n minus 1. Let's check it out. 75 is the third term. So A3 should be 3 times -5 to the 3 minus 2, which is 3 times -5, 3 minus 1 squared, which is 3 times 25, which is 75. Looks like it works. Try it again. Find the 10th term. Did I ask for a term up here? Oh, I didn't find the 10th term. My bad. So let's find the 10th term. I just checked it to see if it worked. going to get a very big number. We'll also get a negative number because it's to a odd power. Using my calculator, I get negative 5, 8, 5, 9, 3, 7, 5. That's a big number. So, write the formula, find the 10th term, write the formula as a fraction, asking for a lot here. R equals negative 1 over 12 divided by 1 over 16, which is the same as that. 3 fours, 4 fours. I don't trust myself. I think I did it right. Let's check. 1/9 over negative 1/12. Negative 4/3. Boy, got lucky. Did that one right. That's A1. So here's my formula up here. AN equals 1 over 16 times negative 4/3 to the n minus 1. And the 10th term, probably going to be a very, very big number again. I'm going to do these separately. I'll do negative 4 to the 9th, so this should be negative. And then I'm going to divide by 16 because I know they'll cancel nice. And on top I get negative 16384. And then I'll do 3 to the 9th on the bottom. And I get 19683 on the bottom. Numbers almost don't mean anything. They're so big. That's how we find the next few terms. And we can find the 10th term, the 100th term, the 5th term, whatever we want. So, last little piece of the puzzle. What we call the geometric means. It's annoying because it's got an S on it, which I wasn't aware of till very recently. When we find the arithmetic mean, no S, well, that's easy. Just add them together. Divide by 2. What we call the average. Well, I put that up there because a lot of people get confused when they do geometric means versus arithmetic means. Throw that out. You will not be using that. How do we find the geometric mean? Well, geometric mean means that it's the term that's missing. As in all algebra, we'll call it x. And, as we just showed before, if it's set up like this, it means the common ratio is x over 2. Or the common ratio is 18 over x. Remember, I've been dividing each term by the previous term. As you may or may not have guessed, I can just set them equal. I've got 2 r's there. So, x over 2 equals 18 over x. Take a guess what we're going to do next. Good guess. X squared equals 36. Square root, x equals, waiting for it, plus or minus 6. Well, isn't that interesting? It could be positive, could be negative. For the time being, assume positive. And that's the geometric mean. 2, 6, 18. 18 divided by 6 is 3. 6 divided by 2 is 3. This pops up a lot in geometry. For example, the altitude of a right triangle when we lie it on its hypotenuse. Draw an altitude straight down, you're going to break this into the geometric mean. So if, for example, this was 4 and this was 9, we'll call this, actually we'll call it h, that's what we usually call it in geometry. We could say 4 over h equals h over 9. We can do that because of similar triangles, but it's the same concept of geometric mean. We get h squared equals 36. Square root of both sides, we get h equals 6. Don't need to know this till we get to geometry, which will be sooner than you think, but it's a nice little concept that similar triangles lead us into A right triangle leads us into geometric means. This actually all ties into the Pythagorean theorem, but we'll get there soon enough. So, one more. Try it on your own if you want. I'll let you pause. And there it is, x equals 18. So, slightly weird end to the unit where we get into geometric series, but it definitely, as you can see, ties in very closely with exponential growth and decay. Good luck.